Hello everyone, I'm Xiao Wang from Tianjin University. In this video, I would like to show you a knowledge graph navigation visual query system, which is called KGNav. For the query, find all signers and actors who have not been directors. Users have to learn sophisticated techniques to customize expressive queries using the query languages such as SPARQL for RDF and Cypher for property graphs. And it's difficult to users to construct correct query patterns without the guidance from the knowledge graph structural information. That's why we claim that such languages lack learnability. And the existing visual query methods like Queryvo and Visage mainly focus more on the detailed construction process of query patterns, which ignores global information in schema layers. As for the ontology visualization tools, they only visualize schema of knowledge graphs and neglect the data layer, which causing the difficulty for users to leverage ontologies to guide their queries on knowledge graphs. So in recent knowledge graph visual query methods, there is an obvious gap between the schema layer and the data layer. By contrast, we can use KGNav to iteratively compress KGs into visual schema graphs that can be easily perceived at a glance to guide queries using the redefined minimum operation unit of knowledge graph schema and a series of useful operators. Therefore, we developed KGNav to serve as a system that can make it easier for non-professional users to understand and explore knowledge graphs and to better bridge the gap between the global information and underlying data through simple operations. This helps to recognize the structure of the knowledge graph, maximize the efficiency of knowledge sharing, and reduce the redundancy of the knowledge. As shown in this slide, KGNav adopts an architecture that consists of three main components: atomic graph generator, knowledge graph schema constructor, and schema navigator. In addition, we provide a succinct and user-friendly graphical user interface to allow users to understand the schema of a knowledge graph and perform query operations on underlying knowledge graph data. I will explain these components in more details later. The first component is the atomic graph generator. In order to better unify the data from the knowledge graph and our schema data, KGNav adopts the concept of hypernodes to construct the data, which is essentially a new entity composed of a set of the other hypernodes with equivalent relations. And for KGS data, each set of equivalent hypernodes in the data is also wrapped into a new hypernode. Once we have a structured data, we can use AGG to assemble the data into atomic graphs. For each hypernode E, LN and out are the set of the labels of the outgoing and incoming edges of E, respectively. Then the corresponding atomic graph of this hypernode is AE, shown in the lower right corner. And L in and L out jointly form the feature F of this atomic graph. So the role of this component is to form a set of atomic graphs from the incoming data and forward it to the next component. The second component is the knowledge graph schema constructor, which adopts an iterative bottom-up construction method. If we given a knowledge graph G as the original data graph, after processing by the AGG component, a set of atomic graphs A1 will be generated from G. Using the set of atomic graphs, a similarity matrix MI is computed and generated. And then this AI is divided into different sides of equivalent hypernodes according to this matrix. Eventually, the result of this around iteration can be abstracted as DI in the graph. The generated KGS DI will be re-input to the AGG components as new data for the next round of the iteration. When DI no longer changes compared to the previous round of iteration, the whole process ends, and we regard DI as the final schema graph. Eventually, this schema graph will be transmitted to the graphical user interface for rendering for users to view and manipulate. The main purpose of the Schema Navigator is mainly to allow users to better manipulate the KGS through combining the query results to satisfy their different query intentions. There are two types of operators defined in this component. The first type of component operators is meta operators applied to atomic graphs, which mainly consist of union, intersection, and difference, which we denote by OP in this slide. As shown here, after operating on the corresponding atomic graphs of hypernodes N1 and N2, the newly generated hypernode N is the set of the hypernodes constructed by operating on the original knowledge graph data that these two hypernodes correspond to. And the feature L in and L out of this atomic graph are extracted from the entire sites of incoming and outgoing edges labels of the internal hypernodes in N. Our second type of the operators, query operators, acts on a schema graph and consists of a complete query operator and a partial query operator. They worked by letting the users set the incoming and outgoing edges label sets, L in and L out, and then use the expected feature of the atomic graph to match hypernodes for querying. The difference between these two operators is that complete query operator requires the target atomic graph to strictly satisfy this feature, where partial query operator only need to satisfy part of the feature. Strictly speaking, the feature of the target nodes must be one of the clean closure of L in and L out respectively. By leveraging both types of operators, KGNav can dynamically record user actions and automatically process the underlying knowledge graph to form a new hypernode for the querying results, and then merge it into the schema graph to provide feedback to the user. As for the graphical user interface, we utilize the graphical GUI shown in this following screenshot, which contains 5 main panels. The first is the KGS display panel, is the main panel for the displaying and manipulating the knowledge graph schema. And for each hypernode, there is also a content preview window and a right-click menu for users better manipulate them. The meta operator panel is a panel specially designed for the meta operators described in the last slide. This panel will turn to active when the user selects two hypernodes at the same time. The KGS list panel is a panel that displays the hierarchical relationships of hypernodes in the schema. When users finally click on an entity node like Michael Jackson, it will switch to the entity information panel, which will include properties and the triples of this entity. The query operator panel provides space for the user to use query operators for queries, and the overall pattern is faceted. And the last panel is the toolbar panel, which provides some other useful tools for better viewing. Next, I will show you how KGNav can perform the aforementioned queries effortlessly. The initial knowledge graph schema presented to users by the system is a concise graph of just 11 nodes formed by continuous iterative compression. However, the underlying data of knowledge graph contains 163 nodes. That's why you can quickly grasp the structural information of a new knowledge graph by using KGNav. When the mouse hovers over a hypernode, you can visualize whether there is a content of interest inside the current hypernode through the content preview panel. Additionally, KGNav has several ways to expand hypernodes of interest for deeper exploration while keeping low interest node collapsed by clicking on the right-click menu, by clicking on a hypernode in the KGS list panel, or by directly clicking on the content preview panel. All three ways are consistent in KGNav. Of course, if there is a clearly specified target, you can quickly get all the nodes contain these underlying nodes through fuzzy search. Therefore, we see that KGNav can make good use of the user's interested concerns to guide users in understanding and exploring knowledge graphs. However, it's obvious that only focus on the simple menu operations cannot satisfy the above query intentions. Therefore, we use the operation operator provided by the KGNav to record all query results, thus providing you with more flexible space for result combination. You can hold down the Shift key and select the two hypernodes, sinner and actor. Then select the activated union operator in the meta operator panel to find all sinners or actors. The result will appear directly on the KGS display panel and the write the KGS list panel as a new hypernode. If you continue to use this result and hypernode director to execute the difference operator, it only takes two operations to complete the query we mentioned at the beginning of this video. These three meta operators give full play to the reusability of the results and can effectively form infinitely complex queries with the simplest operations. In addition, based on the concept of the faceted search, the left side of the KGNav utilizes the query operator panel designed for two query operators. With this panel, you can use edge labels of hypernodes to perform more complex queries and customize the conditional query according to your intentions. For example, let's start in the query by selecting the specified query category all. Then continue to set any number of the incoming and outgoing edge labels with some conditions according to your own query intentions. The KGNav will help you to automatically filter out the correct and valid conditions and discard the wrongly set ones. You can select a query operator from strong and weak, which correspond to complete query operator and partial query operator, respectively. After determining the query operator and executing the query, KGNav will automatically generate the result and display it in the result area. At the same time, KGNav generates a new hypernode in the KGS display panel and the KGS list panel so that the result can be reduced. Continuing to reuse the previous result node, it's also possible to find a node that is either a runner of another node or the winner of that node is Lady Gaga and is also satisfies the requirements that it's an actor and singer who has notable work but has not worked as a director. Of course, you definitely don't need to query and understand the entire knowledge graph during the entire query process, nor do you need to have any advanced reserves of technical expertise. That's all for this demonstration. Thank you for your attention.